Okay, so the first three questions were from number 7, working with rational expressions. And then the next few questions are from number 8, which was working with equations. 7a, we need to simplify this and state any restrictions. The first thing we need to do is find a common denominator. The common denominator is x times x plus 1. To create the common denominator, I'm going to multiply the top and bottom by the same thing that's needed in the bottom. So to achieve the common denominator in the first term, in this term here, we need to have, there's an x already, so we need to have an x plus 1. And that means I need to multiply the top by x plus 1 as well. Similarly over here, I need an x on the bottom, so I need to multiply the top by x. I'm going to keep the denominator and expand the numerators. So using the distributive property, I'm going to figure out what x plus 1 times x plus 1 is. When I expanded this using distributive property, I got x squared plus 2x plus 1. And then of course x times x is just x squared. The simplified answer is 2x plus 1 over x plus 1. The last step is to state the restrictions, and restrictions happen whenever it's possible that there might be a 0 in the denominator. So here x can't be 0, here x plus 1 can't be 0. So our restrictions would be x cannot be 0 or negative 1. In 7b, I'm going to first write it as a multiplication, so I've rewritten it here as a multiplication. Now I'm going to factor each numerator and each denominator. Okay, I've factored each of the tops and bottoms, and here I have an x times 1 minus x squared. I noticed that I have an x plus 1 and x minus 1, which looks like it might cancel with this, but this is not quite in the form I need it, so I'm going to factor out a minus from here, and I'm going to rewrite that right now. And while I do that, I'm actually going to divide out some things that are on top and bottom, so I can simplify a little bit. So that and that can go, and this x can go. So I'm going to rewrite the next line. You can see now with the 1 minus x squared, I factored out a minus, and so I end up with x squared minus 1 inside, which means that when I factor this difference of squares, I'm going to get these two things as well. So even without doing that, I think what I'm going to do, hopefully you realize that this x squared minus 1 factors to x plus 1 and x minus 1, so those cancel out. Then the final answer would be negative 2. Last step is to state the restrictions. X cannot be anything that made any denominator 0. So initially, up here, 2x minus 6 is also denominator, so that's one of those, so we can't forget that one. So x cannot be 3. X cannot be, what else? Negative 1, and it cannot be 0. I believe that's all of them. Oh, and positive 1 also. From here. So from here it can't be negative 1, from here it can't be positive 1, from here it can't be 3, and from here it can't be 0. So hopefully we've got them all. With equations we can work a bit differently. I'm going to actually cross multiply and then solve for x. And now to expand on each side. And now to collect like terms. And now to isolate x. Our final solution then would be x equals negative 1/3. In 8b, I think I would like to clear those denominators, and as you can see I have an x minus 1 and x plus 1, and then an x squared minus 1 on the other side. I know that x squared minus 1 is actually equal to x minus 1 times x plus 1, so I'm going to multiply by every single term by x squared minus 1. Okay, so when I multiply through by x squared minus 1, that's actually the same as multiplying by x plus 1 times x minus 1. When I multiply this term by x plus 1 times x minus 1, the x minus 1s will cancel, and I'm left with the x that's on top from before and the x plus 1 that didn't cancel. In the second one, I'm multiplying this term, 1 over x plus 1 times x plus 1 times x minus 1. So the x plus 1 here and the x plus 1 here will cancel, and I'm left with the 1 from on top and an x minus 1 that went through. When I multiply this term over here by x squared minus 1, this x squared minus 1 will cancel with this one, and I'm left with just a 2. As you can see, I've expanded and then collected like terms, and I'm left with a quadratic that I can now factor. Factored, I get x plus 3, x minus 1 equals 0. Therefore, x equals negative 3 and x equals 1. This is definitely a question where something gets uglier but not harder. So I think just to make it look a little more simple, I'm going to let y be the denominator there, so root x squared plus 4, because then I think I'll know how to solve that equation. Rewriting the equation, I have 0 equals 5 over y minus 2. To clear that denominator, I'm going to multiply everything through by y. Multiply by y, the whole thing. Multiplying through by y cleared the denominator, so I'm not dealing with fractions anymore, so now I'm going to isolate y. Isolating y, I end up with y equals 5 halves. Now I'm going to put our original y with the x in, x squared plus 4, or the square root of x squared plus 4, and put that back in for this y. Putting my y back in as the square root of x squared plus 4, now I'm going to solve this equation, and I'm going to do that to get rid of the square root, I'm going to square both sides. Notice that I cleared the square root over here, and then this side 5 squared is 25, but I also have to do the denominator, so 2 squared is 4. And continue to isolate x. So cleared the square root by squaring both sides. Then I took the 4 over to the other side, became minus 16 over 4, which is the same as 4. I end up with 9 over 4, but that's x squared. Over here, I'm going to now take the square root of both sides. Square root of x squared is x, and the square root of 9 over 4 is plus and minus the square root of 9 over 4, which equals plus and minus 3 over 2. Good job.